Guys, welcome back to another Force in Motion lesson. So far we have learned what force is. Force is a push or pull on an object, and an object will stay at rest until a push or pull, sets it in motion. We've also learned that a motion is an effect of a force. That means motion happens because of a force. We've also learned about different kinds of forces. Gravity, push, pull are applied forces. Friction, spring force, and magnetic force are all different kinds of force. When more than one force acts on an object at one time, then all of those forces acting together on an object are called net force. You can see in this picture air resistance, which is a kind of friction on the bike wheels with the ground, and gravity pressing down on the person. That's three forces just on one person. And of course, he's pushing the bike pedals. So these have more than one force going on at a time. All of those forces acting together are called net force. Today, we are going to be able to describe how the net force on an object determines how an object moves. You'll also be able to write about and label how the net force determines how an object moves. So, remember, net force is just a combination of forces acting on an object. One way to remember net force, it's like a net full of the forces. Literally, that's the way you can think of it. Think of a net full of all the forces. If an object stands still, then there is no motion. In other words, there is no force acting on this object. There's no one pushing the object, no one pulling him. So he just stands there. No force means he has no net force or zero net force. Sometimes there is more than one force pushing and pulling an object in opposite directions, but the amount of pushing is the same as the amount of pulling. They balance to zero net force, and they make the object stay still, even though there's a force being applied. Here you can see this is the object. There's force being applied to the left, force being applied over here. Okay, same amount of force. The net force equals zero, and it stays still. Equal amounts of force in opposite directions result in zero net force, the object staying still. If the net force of an object is zero, then the forces are balanced. Balanced forces will not cause a change in an object's motion. The object will stay still. Here are some more examples of balanced forces. The force of air resistance and friction acting against the skater's push is balanced. They're the same amount of effort. So the push of the skater and the air resistance and friction are equal amounts. So he's able to balance at the skateboard. Okay, the amount of gravity pushing you down is equal to the push from the floor that supports you, holding you up. Okay, again, we see the skater, the amount the gravity is pushing him down and the amount that the ground is pushing upward on the person is equal to each other. The amount the weight of the person is pushing down on the chair from gravity, okay, is equal to the amount that the chair is pushing up on them. And also, here we have the picture of an object with two fingers pushing equal force on both sides. So it stays still, doesn't move. However, when there is one force acting on an object, but the one force is greater than the other one, then the forces are unbalanced. Unbalanced forces will cause a change in motion. The object will move. It might speed up, slow down, or change direction. Here you can see there's an object. There's a weak force pushing it to the right, but there's a really strong force pushing it on the left. the object will move to the left because the force over here is stronger. That means the net force is to the left. This unbalanced force will cause a change in motion. The object will move, it will speed up, slow down, or change direction. Unbalanced forces will cause an object to speed up, slow down, or change direction. In other words, an unbalanced force acting on an object will cause the object to accelerate. Acceleration is the change of speed and direction over time because of an unbalanced force acting on an object. Here's some examples of acceleration. This guy is accelerating because they're speeding up. This guy is accelerating because he's slowing down. And this guy is accelerating because he's changing directions. Here are some more examples of unbalanced forces. Okay, when they're playing tug of rope, this guy's not pulling as much as this guy is. He's pulling a lot more, so he's winning the tug of war. Okay, the bird dropping down to the ground, his weight is more than the force of friction. Okay, and then here we've got a truck moving. We've also got a rocket lifting off the ground. Here's another way to think about a balanced or unbalanced net force. We'll use arm wrestling to help us understand. Have you ever seen someone arm wrestle and they were equally strong? Their arms just stay in the middle shaking. This is because the net force is balanced. The forces being applied on both sides are equal amounts, so the hands can't go anywhere. They stay in the middle. But when one person is stronger in the arm wrestling match, the other person's arm goes down quickly. The forces on the hand were unbalanced. The net force was unbalanced, making the hand move. All of this is Newton's first law of motion. It says an object in motion will remain in motion, and an object at rest will remain at rest unless acted on by an unbalanced force. And here's a picture of Isaac Newton, who made the law, saying, "Objects keep on doing what they're doing." Okay, so now it's your turn to tell me which ones are at zero net force, okay, and which ones are not at zero net force. Move the green box to label the picture. Also, tell me in this sticky note box how net force affects the motion of an object. What happens when it's at zero net force to the motion, and what happens when it's an unbalanced net force. Okay, guys, go ahead, give that a try now.